Good morning, student. Can you hear me? Good morning. Can you hear me? Yes, okay. I'm waiting for others to join in for today's lesson as well. Still 11 participants are there. First of all, wish you all a very happy new year. I think this will be the first lecture after the new year. You can see my screen as well, right? I'd like to hear your voices as well. Can you hear me? Okay, better if you can switch on your mics and speak. Let's start the lesson straightly. I think you have another lecture by 10 a.m. So I'll try to finish it as soon as possible so you can have a small break before the next lesson, next lecture. So today we are going to talk about the economic aspects of design decisions. This is mainly focused on the design stage, not the construction stage. In this lesson, we are mainly focused on the design stage. We know that we have two stages of any construction work, which is the design stage and construction stage, and later we have the maintenance stage as well. So in this lesson, we are mainly focusing on the design stage. So economic aspects related to the design decisions. In particularly, we are mostly focusing on the sustainable aspects of the design decisions as well. Apart from the economic aspects, the sustainability is also given a priority in this particular lesson. So if I move forward, as an introduction, the basis of design decisions will be relied on the economic aspects. So we consider the economic aspects whenever we do the designs, building designs, construction designs, highway designs. For any design, we have to give a priority for the economic aspects as well, because at the end of the day, the money will be spent on all of these construction work. So designing a technically safe and sound system will be only part of designer's task. So mainly the designer's task is designing a technically safe as well as sound system. At the same time, he should also aware of the economic aspects of the particular construction work as well. So any construction project should be economical and it should show an adequate return on investment. We have a term called as return on investment. Return on investment in the sense, how long will it take to pay back whatever the investment that we have made on a particular construction work. ROI in simple terms, return of investment. So if the return of investment is high or longer, that means it takes longer time to pay back whatever the investment we made. After that period only, we will make profit through that particular construction. Up to that particular point, we are only covering our cost or the investment. In the building industry, a vital element of any economy, like what it says is actually the building industry is a vital element of any economy. So it plays a major role in any economy of any country. And it has a significant impact on the environment as well. That is why we need to consider the sustainability aspects of building industry as well, because it has a greater impact on the environment as well. The construction is one of the largest users of energy, material, and other resources as well as water. Construction industry is the largest user of any energy, materials, resources, and water. Therefore, we should make sure whatever the construction work that we are dealing with is economically viable as well as sustainable. We should maintain the impact to the environment as well. In the construction industry, it attempts to produce buildings with a lower environment impact as possible. You might have heard the carbon footprint of any building, which refers to the environmental impact of a construction work. So that is the point where this sustainability comes into play. In the construction industry nowadays, the trend is they're attempting to make the construction work more sustainable. That in the sense, in other words, lower environmental impact as possible. Sustainability is an important issue to consider from the early design stage, not only in the construction stage. We should consider it in the design stage as well. And it is not only due to the environmental concerns, but it is also due to the economic and social matters as well. We can't categorize sustainability only into the environmental concerns. Sustainability has a greater relationship with the economic aspects as well as the social matters as well. It promotes the architectural quality of a building, and it gives us an economical advantage through it as well. So that is why the sustainability is also important in this particular concern. So there's a quote quoted from a particular textbook. It says, instead of trying to force fit sustainable principles into an existing or often unreceptive manufacturing system, it may be useful to approach the subject from the opposite direction and consider how functional objects might be designed and manufactured to be compatible with principles of sustainable development. What it simply says is, it is not easy to forcefully fit sustainable principles into already constructed buildings. But it is easier to apply these sustainable principles from the early design stage and do the construction work. So at the end of the day, we have sustainable development in the industry. So that is what it says in this particular quote. Instead of trying to force fit sustainable principles into an existing and often unreceptive manufacturing system, it may be useful to approach the subject from the opposite direction. What is the opposite direction? That is, starting from the early design stage, considering how functional objects might be designed and manufactured to be compatible with the principles of sustainable development. Are we clear up to this point? Any questions in the introduction part? Later, we will be moving into some mathematical parts in this lesson, and there you will get an assignment today as well, which you need to submit within this week. Are we clear up to this point? Can we move forward? Any questions? I think I have shared this presentation before as well. All clear up to this point? Can one of you confirm whether you have any questions? Okay. So when it comes to the sustainable development, sustainability cannot only be achieved considering environmental aspects. We should consider all three aspects of environment, social, and economic. So in order to have a sustainable development, we should consider the environmental aspect, social aspect, and economic aspect. That means it a particular construction project or a building should be environmentally sustainable, socially sustainable, as well as economically sustainable. By definition, sustainable development is the practice of using guidelines for an environmentally responsible, economically viable, and socially acceptable manner to create new development projects and to maintain the retrofit older projects. So we have three important terms here. A project should be economically viable, socially acceptable, environmentally responsible. You can see in this diagram, if the project is environmentally responsible and socially viable, but economically not sufficient, then it will be a sustainable, natural and built environment, but it is not economically viable. If it is environmentally and economically viable, but not socially viable, then it becomes a sustainable economic development. If it is socially and economically viable, but not environmentally viable, then it becomes equitable social environment. In order to have a sustainable development, we should make sure it is environmentally responsible, economically viable, as well as socially acceptable. This is how we basically define the sustainable development. So any improvement of the building's sustainability performance must begin already from the design stage. As the potential of optimization in project early phases is higher and the impacts of changes of the building and the construction costs are low. If we try to apply the sustainable aspects in the early design stage, it is very easy to apply because the potential of optimization in project in early design spaces are easier or higher. And the impacts of changes to the building and the construction costs are lower in early design stage. You can see in this diagram, which represents actually a chart which represents x-axis representing the time of the construction work. Y-axis representing the environmental impacts and costs. So you can see, first we have the planning stage. So from 0 to a particular instance, the time it takes for the planning. Then only planning, in the sense it includes the designing part as well. Then only we start the construction work. After completing the construction work, we have the maintenance part. So if you try to apply the sustainability aspects earlier in this planning stage, it will be less costly. But if you try to apply it in construction phase, it will be much higher. And if you try to apply the sustainable aspects in the maintenance stage, it will be cost more. So you can see in this diagram, impacts and cost of planning is representing this line. So impacts and cost of planning from here to here. Impacts and cost during the using phase here. Impacts and cost during the construction phase in here. This curve representing the possibility to influence the impacts. So you can see in the planning stage, the possibility to influence the impacts are higher. But when it comes to the construction stage, the possibility to influence the impacts and the costs are becoming lower, and it further lowers down when it comes to the maintenance stage. On the other hand, impacts to the cost is lower in the planning stage, but the impacts to the cost is becoming higher when it comes to the construction and maintenance stages. So cost will be higher if you try to apply the sustainable aspects into the project in construction or maintenance stage, but it will be lower if you try to do it in the early planning stage. And the possibility of influencing the impacts is higher in early planning stage, but it will be getting lower when it comes to the construction and maintenance stage. Clear? Are we clear? Any questions? Do we have any questions to be clarified? No questions? Moving forward then. We should know the project cycle in order to consider the sustainable aspects as well as specifically the economical aspects of a project. So the project cycle is mainly consists of 6 main stages. What are these 6 main stages? The first one is the project concept. Second one is the pre-feasibility stage. Third is the feasibility stage. Fourth is the design and engineering stage. Fifth is implementation or the construction. And sixth is monitoring and evaluation. So you can see in these 6 stages, before it comes to the construction work, there are 4 main stages to be passed. The project concept is to be finalized, then the pre-feasibility, then the feasibility, Then only we can move on to the design and engineering. After that only we are moving into the construction work or the implementation. Then the monitoring and evaluation. So this is the generalized project cycle in any construction work. Okay. So you can see in this diagram how this design stage and the construction stage of a project is being changed. In the left side, you have the design stage. In the right side, you have the construction phase. In the design stage, we mainly take the design decisions and the preliminary supplier selection is then applied, then take place. Then only we are moving into the logistic part, how to store them, how warehousing and how to transport them, the transportation part. Then only we are moving to the construction stage and the delivery stage. This is how a particular construction work being done from design stage to the construction phase. Before the design stage, of course, we have the project concept, pre-feasibility and feasibility. Then when move on to the design stage, we have the design decision, preliminary supply selection, then the logistics part, construction stage and the delivery stage. So in the design decision stage, this distribution of suppliers, the availability of resources and the BIM modeling, business information modeling, detailed takeoff and properties will take place. And when it comes to the supply selection, from a database, we will select who are the best suitable suppliers for different supplies, the GIS modeling, and the selection based on HP and GR. After selecting the suppliers only, we can move on to the logistics, how to store them, how to transport them, the status of the materials, the storekeeping, the selection again when an emergency occurs. How we have to have some suppliers for an emergency situations as well. After doing the logistic part, only we can go on to the construction stage. And this logistic part and the construction stage, it is an ongoing process. In the construction stage, we update the status of the materials into the BIM model. We handle any variations in the prices, any variations in the stocks, designs, anything. We have to compare the particular plan with the actual situation. And if needed, we might need to have some suppliers for emergency situations as well. After completing all these stages only, we can come into the delivery stage. Before delivering, the construction work should be accepted mainly by the consultant, and then only we can do the delivery. Delivery in the sense we are handing over the particular work to the client. Okay, so now we are moving on to the economic factors in the design stage. So what are the economic factors in this design stage? These are the economic factors which should be considered while making the investment decisions. Mainly, these are not only the economic factors that we should consider, but these are the main economic factors we should consider while making an investment decision, whether to invest on a particular project or not. we should consider in the design stage whether the capital cost of the technology can be affordable. So in order to do this particular construction work, a particular technology might be needed. Do we have the capital cost for that particular technology, or is it affordable? And the availability of the long-term debt. Are we having long-term debts or not? Then the capacity, which most importantly, we should be aware whether we have the capacity to do this particular construction work. Based on that only, we should design the particular work. If we don't have such capacity, we should not go for a higher designs. And we should be aware of any risks and the uncertainties. Whether we have any risks on this particular construction work or whether we have any uncertainties. So we should be well aware of those things as well. And the other important thing is the time, because in construction work, we believe that time is money. So we should be aware whether we have enough or sufficient time to do a particular construction work. It should not be excess time. It should not be short of time. And the rate of inflation. But sadly, in local conditions, in these days, we can't predict the inflation, which is rising very high. Anyway, we should have and better understanding on the rate of inflation when it comes to the design stage of any construction work as well, because we can't design a particular work only considering the market values or the market prices of the resources and the labors as in the current condition. We should be aware of the inflation, and we should aware how much of increase will happen in the ongoing time of the construction project. And we should have a good understanding on the competitors as well. We should have a competitive advantage in that particular scenario. You know, in any construction field, for any material as well as for any labor, as well as for any construction company, they have some competitors. So we should be aware of those competitors, and we should take an advantage over them by utilizing our resources. Then the liquidity as well as the taxes. So you can see how the economic factors affect in the design stage through these points. It's not only the civil engineering aspects. We should consider the economic aspects of a particular construction work starting early in the design stage as well. As I said earlier, in construction work, time is money. Therefore, cycle time, that means the time it takes for the construction period, is an important factor because that time is a measure of money. Ensuring the revenues as fast as possible is a priority to the client or the investor. We should ensure that the revenues will come into hand as fast as possible. If the construction period or the cycle time is lower, then the capital cost is also lower. If the construction period or the cycle time is lower, then the capital cost is also low. There are several methods that we can evaluate the alternatives in design in terms of economics. So let's look into what are the methods that we can use to evaluate a design alternatives in terms of the building economic side. Here we have several economic analyses that we can use in order to compare different design alternatives in order to identify the most suitable or most economical method or the design to be utilized. So this is the part where you get the assignment today as well. We'll be mainly defining these terms IRR, ROI, and NPV, and you will receive an assignment in which you need to do that particular question. Actually, we have 3 questions. You need to do those 3 questions, not only looking into the definitions, but also searching some other facts from the internet as well. There are various methods for economic evaluation of design alternatives. Among them, these are the profitability analysis of design alternatives, which are most commonly used in the industry. We use this IRR method, which called as internal rate of return. We have the ROI, return of investment. Then we have the net present value, NPV, and the payback period, as well as simple rate of return, SRR. So this IRR and ROI as well as the NPV are discounted methods because they take into consideration the entire life of a project and the time factor by discontinuing the future inflows and outflows of their present values. So this in ROI method and NPV as well as the IRR method, the internal rate of return, return of investment, and the net present values, they are discounted methods because they take into consideration the entire life cycle of the project. So the time factor by discounting the future inflows and future outflows to their present values. So they have some sense for the inflation rates as well. But the simple rate of return and the payback period are 2 other methods used for profitability analysis only. They are usually referred to as simple methods since they do not take into consideration the whole lifespan of the project. So they don't have any consideration over the inflation rates as well. So due to those reasons, we are mainly focusing on the first 3, ROI, NPV, and IRR method. So if we first identify the time value of money, this is very important. We should have a good sense on the time value of money. A sum of money is more valuable the sooner it is received. That is, for an example, let's say a rupee today is worth more than a promise of a rupee tomorrow. That is due to the inflation. Any other currency as well, it will be same. A dollar today is worth more than a promise of a dollar tomorrow. That simply means if you have 1 rupee today, what you can do from that particular 1 rupee in today will not be same if you try to do that particular thing in another 1 week time or another 1 year's time. Because the time value of money is changing. This is mainly due to the inflation. So before investing money into a project, the rate of return against the opportunities in the sense rate of return against the other alternatives should be compared. So to identify the time value of money, we can use this equation. This is very important equation which you need to use in your assignment as well. Time value of money equals to, so the future value of the investment or the future value of the money is equal to the present value of the investment into 1 plus interest rate or the discount rate, or in other words, cost of capital, into the power of number of years. So the future value of the investment is equal to present value of the investment into 1 plus the interest rate into the power of number of years. Then we are moving into the net present value analysis, NPV. In the NPV method, it is a method of calculating the expected net monetary gain. Monetary gain in the sense, the cash gain. Expected net monetary gain or the net monetary loss from a project by discounting all future costs and benefits to the present time. We are discounting all the future costs and benefits to the present time in order to take the expected net monetary gain or the loss. Projects with a positive NPV should be considered if financial value is a key creation or key criteria. Project with a positive NPV should be considered if financial value is a key criteria. That in the sense, if you have 2 or 3 alternatives with different NPV values, you should always go for the positive NPV value if you are considering the financial value of the project as a key criteria. Generally, higher the NPV, better the project. So if you have multiple alternatives to be chosen, the alternative with the higher NPV, higher positive NPV should be chosen. That should be that is the better project. So in order to calculate the NPV value, we can use this formula. NPV is equal to the sum of the net cash flow divided by 1 plus I into the power of T. I is the discount rate, T is the time. Any questions up to this point? These are very important parts of the lesson which you will take the assignment as well. Any questions? No questions? Okay, can we use PVIF table for calculate the NPV? Can you elaborate PVIF table? What is PVIF table you are referring to? You mean the present value interest factor table? Is it the PVIF table that you are referring to? if you are referring to that particular table, PVI in the sense present value interest factor table, yes, you can use it because that table is mainly depending on the equation that we define here. Is that table you are referring to, person? Yes. PVIF in the sense, I hope you are referring to present value interest factor, right? PVIF stand for a table where you have the year in the row headings and the interest rate in the column headings. Am I correct? Yes, yeah, you can use that table because that table is mainly depending on this particular equation. Those values are taken by calculating the values from using this equation. So you can use that. Okay. Do you have any other questions? Let's move on to the internal rate of return, IRR. The IRR is also similar to the NPV in process, but it has some slight changes and it is more difficult to calculate. The IRR is a discount rate at which NPV is 0. At the point where the net present value is 0, the discount rate is what we call as the IRR. So finding the IRR solution involves trial and error method. Trial and error method, you might be aware of these trial and error methods where we are trying to plug some different discount rates and see which one drives to the NPV of 0. So we don't know at exact discount rate of which the NPV becomes 0. So we are trying to add some different discount rates. That means we are trying to do some trials and identify what is the NPV value. What is the discount rate which makes NPV value into 0. So we have some trials and we keep on doing some errors, and keeping on doing the trial and errors, only we can find the correct answer. So it is a bit difficult method because it consumes more time. You can compare the IRR value to other projects or to a company standard in order to see which project should be get priority. So in order to prioritize the projects, we can use this IRR method. If the organization has set a minimum value of 8% and the project IRR is 15%, so you have a positive situation and you should do the project. Let's say the company has defined a minimum IRR or the minimum percentage of 8% for the internal rate of return, but the project itself has an internal rate of return of 15%, then of course it should be a viable project to be chosen. If the project IRR turns out to be 6%, you should not do that particular project. So basically this IRR is internal rate of return which used to find or which used to identify or compare the projects of a particular company standard. So we can compare projects with other projects as well as we can compare a project with the company standard. So what is the best project kind of? Okay. So these are the main 3 definitions that you need to know. As well, the assignment is only based on the first 2 definitions, time value of money and the NPV analysis. It is not depending on the IRR values. So you can try to do this assignment using these two definitions. Time value of money. So how to calculate the time value of money? The future value is equals to present value into 1 plus interest rate into the power of number of years. So you can use this equation to do these two questions. The first question asks to invest $1,000 today, that is the present value, for 1 year, that is the N, at an interest rate of 10%. What is the worth of this investment at the end of the year? Remember, students, this interest rate 10% should not be applied as 10 into this I. 10% in the sense it is 0.1. So you can use that equation for the first question. The second question, you have a project that promises you $1,000 of profit at the end of the first year with a discount rate of 10%. So you should identify what is this $1,000, whether it is the present value or the future value, and what are the terms that they have given, the 10% of discount rate the first year, and what is the present worth of the project. These two are very simple questions that you can score more marks. And the third question is regarding the NPV. Consider the interest rate or the discount rate of 8% per annum in the sense per year, and select the most feasible option. The most feasible project. So do an NPV analysis and identify whether project 1 or project 2 are the most feasible projects to be chosen. Are we clear on this assignment question? Any questions that you need to clarify? Okay, anyone with any questions? Because this is actually the lesson that we missed at that day due to a function that you had, and I just wanted to go through that lesson quickly and give you the assignment, because otherwise without going through the lesson, if I give you the assignment, I don't think it will be more feasible for you. So since you don't have any lectures tomorrow, can we can all of you submit the assignment by end of tomorrow? So I'll create a link in the LMS in order to submit the assignment. So you can do the work in a piece of paper and either scan it through your mobile phones or whatever the scanner app, and upload your answer to the Moodle or the LMS. So I'll create a particular link to the uploads, and then it will be marked as your first assignment. I will not take the assignment that we were discussed on the previous day, which is regarding a small definition. So we will take this as the first assignment of the module, and you will not have any lectures tomorrow, and we will have another lecture in next Monday as well as in the Tuesday. Is it fine? Only for next Monday also we will have another lesson. Then only we will go through the exact timetable, which we do lectures only on Tuesdays. Are we clear? And please pass the message to the absentees as well. Ask them to do the assignment today or tomorrow itself and upload it before tomorrow midnight. I'll not mark any assignments which receive after the deadline. Please ask them to submit the assignment by tomorrow night. This is not a hard assignment, very a small one, very simple one. So where you can score some marks. Are we clear? Yes, please ask all the students to do the assignment. This lecture note is already available in the Moodle. I will upload the video recording today as well. So ask the absentees to do it as well. And all of you should submit the assignment before tomorrow night. Tomorrow night in the sense tomorrow night 12 p.m. Any submissions after that will not be marked. Anything that you need to clarify before winding up the session? Anything? No? Okay. So let's wind up the session for today. And we'll be again meeting on next Monday, 8 a.m. for the next lesson. Please do the assignment and ask the absentees to do it so as well. I don't want to give zero for any of the students. Thank you for your cooperation, guys. Have a good day.